For a moment, Amanda, I was taken aback. I thought you were a student named Marissa who graduated years ago. And but then I looked more closely, and in fact, you are a separate human being. So
Yeah, my name's not Marissa.
right, I salute your individualness. Okay, so you notice that there are two of me, and that is because I am running a second instance of Zoom so that I can see whatever it is that you're supposed to be seeing. And I can pay attention to what's going on in class. Actually, it might be a good idea if instead of looking at what you're supposed to see, if I instead maintain the gallery, but then again, as soon as who cares? I don't really want to see you. No, I really do. Okay. Okay, this is computer organization, and it's a required course. So if you don't succeed in it, you don't move on in your computer science major. So it's an important course. It's got a lot of really important material. You're going to get a sense of what computers really do when they run your programs, how things work under the hood, and in some ways, this might be among the most important courses, CS courses that you take. So I have here so far a very brief agenda. Let's take a look. We'll go over the syllabus, then start looking at GitHub, not the usage of GitHub, the class GitHub repo. And then also we'll start talking about installation of the environment. And then after that, we will go over one of the AMD documents. Oh, I'm having a little trouble with manipulating my hands today. Could be the stroke. Go over one of the AMD docs. All right. So let me flip over to the syllabus. And that would be here. So going to the class Schoology page, you see that I've begun organizing. There are the specifications for your projects, important reference material for you, and the syllabus. A word about what you see on the right-hand side, your homework assignments that are due, these projects. It is my practice going forward to, rather than keep assignments secret, instead, I will publish them as far in advance as is reasonable for me to do so. And what this means is you can get to look at them. You might even begin them if you do a project early. The favor that I ask of you is do not hand them in until they're due. Okay, so ordinarily an instructor would not allow you to see P2 until it was time to assign P2. I figure, what the hell? I'll give you some advance information. You can begin reading the specifications, perhaps thinking about what the project is all about, and you might do better. I started doing this for the operating systems course in the fall, where I published 3 out of 6 projects in May of the previous May, and found it was tremendously successful in that everyone in the class did the projects before the start of the term. Actually, that's completely false. Not a single goddamn one of the students did it during the summer, but hey, that's their problem, not mine. But I figured it was a good practice. Why keep it
Wait,
secret?
wait, 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 wait.
Did you do any of them,
I
Cephas?
did like 95% of one. And
95%
then I
of
just, yeah, and then I submitted it pretty much immediately. So
okay.
I
All
resent
right.
your words.
Well, then let me modify my words. Uh, Truncating to the integers, you accomplished 0 of the projects.
Oh,
Uh,
what? No.
if it was 95%,
I
truncate it down
I
to 0. Yeah.
I round up.
Okay. Well, unfortunately for you, I'm the one who assigns the grades. So this is all in good fun. Everybody, Cephas and I are going to uh, do point counterpoint. I appreciate no matter what it is
I
that I
mean,
say and how I behave towards Cephas.
at least you look like Jack Black.
I value his. I look like Jack Black.
You look somewhat similar to an old Jack Black, yes. At least to me.
I mean, Jack Black is an old Jack Black.
Jack Black is young compared to me. Okay. So anyway, I value everyone in the class. I especially value Cephas because he's so much fun. He's a challenge, right? And it's a challenge I enjoy sometimes. Okay, so let's go to the syllabus. All right. So the intent of the course is to give you an indication of what really happens on computers. Because prior to this course, everything that you've experienced is an upper level abstraction. So in this course, you'll find out what's really going on. And the intent is that by understanding what's really going on, you'll be able to master the higher level abstractions and wield them in a more advanced, more knowledgeable way. All right, so in this course, we are going to learn the 64-bit ARM architecture, instruction set architecture. It's called Arch or Arch 64 ISA. And that is not a common thing in courses like this. Every computer science program has a course like this, but it is rare for a course like this to teach the ARM architecture. Typically, you might learn the MIPS architecture, and I think that's kind of a bad idea because while the MIPS instruction set is very nice to teach, how many of you have sat down in front of a MIPS computer recently? Well, here's the bottom line. All of you have. The only place MIPS is really used anymore is in the computers inside cars, because they make one that is like fireproof. But anyway, so typically the MIPS architecture is taught. The MIPS is waning, and instead the Intel x86 architecture is taught, and that, frankly, is an abortion mixed in with food poisoning. So you don't really. I don't want to teach it. And it's really disgusting. The reason why is it is backwards compatible with the instruction set that they introduced in the late 70s. So you just have one bad idea after another, compounding to produce what is today a dog's breakfast of eras and epochs all jammed together. Now, on the other hand, the ARM architecture is both elegant and is also germane in that every single one of you who has a phone without going out on a limb, every single one of you has a 64-bit ARM machine in your pocket. In fact, after taking this course, you literally would be able to write assembly language applications for your phone. That's why I choose the ARM architecture. We're learning the 64-bit version because 64 is a bigger number than 32. 32 is old, passé. Why not go for the best? You guys deserve the best, and that's why we're doing the 64-bit architecture. We're going to, if you have not been exposed to the Linux environment, the command line environment especially, yet you will be in this course. So finally, you are taking off the training wheels, putting your dumb old GUIs aside and going to where the real CS people do their work. You'll be learning a lot about bitwise operations, which probably you have not done much of so far. We'll find out how computers store and use numbers, and we will learn a little bit about parallel programming and synchronization of tasks that are executing in parallel. There's a lot of material here. It's an awful lot of fun. Oh yeah, so let's put down, all right, and we'll probably do this first. Friendly words, don't panic. Let's go back here. Let me close my door. Okay, there is no textbook in the class. It's because they are, in this subject, they are really expensive. Typical textbook in this class is $150, and there's no textbook that is right for me in this course. So I have provided you a number of documents and reference material on the GitHub page. You are expected to make use of those reference documents, and I'm saving you $150. Okay, here's your extra credit. It's built into the course. Notice 90, 10, and 10 adds up to 110. Okay, there'll be a midterm and a final. Final is cumulative. They will be administered on or via Schoology. They will be multiple choice, either exclusively multiple choice or, if not, almost certainly, not almost, but certainly mostly multiple choice. The bulk of the work, a bulk of your grade is in the projects and the other homework. Don't ask for extra credit because, as you can see, it's already built in. Okay. Any questions so far? I think Thomas has one.
How are late assignments being handled? Like you turn it in a day late because something stupid happens.
I'm curious, what sort of stupid things do you expect to do?
Be myself, which means completely and utterly forget how 1 + 1 = 2 for a moment and mess up some code and then have to fix everything.
Okay. All right. Well, some of you have had me before and some of you have not. You have not.
Nope.
So those of you who have had me before have been lucky enough to have me before. Let me play along with me. All right, Thomas, there's no late days. If you're a minute late on the assignment, screw you. Too bad.
Thank you for being so reassuring.
Okay. Now, everybody who has had me before, what do you think? Do you think that answer is accurate?
No.
Okay. Generally, Thomas, I will come back to you and back to you and back to you, begging you to turn in the assignment, even if it is late. Okay?
I'll
So-
probably also be asking a lot of questions of what the heck does this stupid thing mean, or how am I being so stupid in this particular instance, because I ask for help a lot.
Then you and I are going to be best friends. Okay? Because it's in the syllabus, and I'll get to it. Why not now? This is critical. I bloody hated last term. It sucked. It was the worst experience I have ever had as an instructor, and I'm not going to repeat it. And you want to know what'll fix it, what you can do to have me have a wonderful experience? Do exactly what Thomas just said he would do. So I'm going to take you at your word. Thomas, I'm going to hold you to it. If you ask me questions, if you talk, you don't have to raise your hand, interrupt. Well, most of you can interrupt. One of you the other person who can't interrupt, he knows who he is, but he knows I'm joking. So I'm telling you, if you're all silent and you don't interact with me and each other, then God damn it, I will stop this car right here, turn it around, and we're not going to the zoo. Okay?
I have a
So,
question.
yeah, go ahead. Stop interrupting me. No, go ahead.
Our term wasn't that bad. Our class wasn't.
Maybe from your perspective.
I remember interacting with you.
Yes, you did. Yeah. So, but you weren't the only class that I taught. So, to make instruction by being a student over Zoom sucks, right? Being an instructor over Zoom sucks more, right? So the only advantages I have is I don't have to do the homework, which is not true too, because whenever I assign a project, I have to do the
Actually,
project.
there's
before I
probably
assign
one
it.
benefit to working in Zoom, that being you can record the class and go, okay, if you need to look back at it, here you go.
Yes, but there are some advantages to doing Zoom. But getting back to my point, if you folks are lifeless, this is going to be a painful 14 weeks. So if you want to make this fun and you want to make the instructor have fun, which by the way is really in your best interest, then all you got to do is talk. Okay? Okay. Now, are you okay. Looks like I have a new Travis Dillard. Okay. No, nobody here knew Travis, right? Because you're all too young. Yeah. Okay. Jordan, you got competition for my favorite student status. Okay. So
This means war.
What?
This means war.
This means war. Yeah. Start. Can you juggle? Now would be a good time to juggle.
I can juggle a bunch of assignments.
Oh, good for you.
I think we can all manage to do that.
Yeah. Okay, now occasionally, possibly, maybe not, I will take one of your projects and present it in class. It's not intended for punitive purposes. It's instead intended for constructive purposes. Maybe there's some magnificent bug you have. Maybe there's some magnificent innovation you have, and I want to share it with others. I'll remove names, so but don't feel put upon if I happen to present some of your code. All right, so that's not the purpose. It's a constructive purpose. Here's the link to the class GitHub page. We'll visit the GitHub page next. The installation and instructions for the environment is a link given there. We're going to use Kimu. Kimu is a virtual machine system. It's open source. It's free. And something that's remarkable about it is how generic it is. So when you follow these instructions and you install Kimu, you're actually going to be installing dozens of versions of QEMU, which will allow you to emulate basically every processor ever made. So we're going to be using QEMU to emulate a 64-bit ARM Cortex V8, and you could, at the same time, there'll be other versions of QEMU on your machine where you could run a virtual Mac, a virtual Windows machine, whatever. So we'll be using QEMU to virtualize and emulate the ARM instruction set on your x86 computer. Now, I just bought one of these M1 based Macs, which is an ARM 64-bit machine, and I still have to use QEMU. So the M1 based Mac is emulating the x86 so it can emulate an ARM. Such is the way it is. Someday it'll go.
That sounds unnecessarily complicated.
Well, it's we take what the authors give us.
Then again, it is a Mac, so that's understandable.
Yep. Yeah.
So wait, why can't you natively program ARM on the M1 architecture?
Oh yeah. You would think, right? It turns out that, well, I don't know if anybody here has. All right, I tell you what. I'm going to be silent for a moment, take this drink, and then someone who knows me can tell everybody else what I think of the Mac.
My parents told me not to use that language.
Okay, fair enough.
Okay, I know you, but I have no idea what that's supposed to mean.
I hate the Mac. That's
Everyone hates the Mac,
Says
except
the guy who has like 3 of them. What?
No,
I'm so confused.
I have 2 iPads, 2 iPhones, 5 Macs.
I rest my case.
Yeah. So the problem. Yep. So the problem with not being able to use the M1 directly is, well, it's Apple. Okay, why does it work like that? Because Apple. That is actually syntactically a complete sentence. Because Apple. It turns out that even though the Mac is a Unix machine, they chose to use a different calling sequence, which is something that you're going to learn real soon now, a different calling sequence than Linux does. So it means that I can't write assembly language that works on both Linux and the Mac. That's why I have to use an emulator to run an ARM-based Linux machine on an ARM-based Mac. So why? Because Apple. All right. So that's about the environment. We'll do the installs. Accommodations. This language is mandated by the college. I'm very accommodating. Or I'm not accommodating at all, which I'll tell you I have no accommodations whatsoever, and then I'll bend over backwards to accommodate your needs. That's just me. That's the in-joke. Don't tell anybody I'm actually a nice person. A note about accessibility, similar. About the learning outcomes. In the old days, car commercials used to say, you'll get 19 miles per gallon. Your mileage may vary. Right? So they make a claim that you'll get some benefit, and then they have to qualify that claim by saying, well, the claim actually, there's no evidence that the claim will happen for you personally. Now, in the case of the learning outcomes, I'm going to do my best to prepare for you and present to you a great class. Whether or not you learn, whether or not you dig what I'm laying down is up to you. Your mileage may vary. I may change the course. So don't come back to me and say, well, you didn't, such and such was not in the syllabus. I will simply look at you and say, well, the possibility that I would change the content in the course is in the syllabus, so thank you for your concern. Go away. All right. Academic success and health. Take a look at me. I am the very picture of physical fitness. Um, uh, so obviously not. This is clearly a case of do as I say, not as I did. All right. I'm overweight, inflexible tub of lard, but you don't have to be. So it's really, get off your ass and go exercise. Okay? That it's really important that as a CS student, you keep in mind that there's a whole world out there and not everything happens in a chair in front of a computer. So it's vital to your long-term health that you don't do what I did.
Lots of important things do happen in a chair behind a computer, though, at least nowadays.
Right. Now, office hours, I do not publish office hours. The reason for that is these days, any hour can be an office hour. I have found that if I say that Tuesdays at 3 o'clock is my office hour, there's going to be a lot of people who can't come, right? So no matter what hours I pick for office hours, there are going to be people in class who can't make it. So instead, any hour of any day can potentially be an office hour. Just go on to Google Calendar. Everybody has it. All of you have it. And you can access my calendar, see where I have openings, schedule an appointment request, make sure you send me an invitation, and if I can meet then, I'll meet then. Okay? So it's instead of me dictating when the office hours will be, and of course getting it wrong for some of you, you determine when the office hours are, okay? Okay, let's talk about academic honesty. This class is a required class, and it's an advanced class. So it's required, so therefore I think it's important, and the material is important for you to become proficient practitioners in the art of computer science. And it's also an advanced course, which means there's, even though it's technically true, there's an infinite number of ways to do a Hello World program. In practice, there are very few ways to do Hello World. So it's likely that people in 1810 will hand in identical code. Okay, I get that. But in this class, your projects will mushroom into the hundreds of lines, and it's going to be damn trivial for me to spot you cheating. So don't do it. In this class, I will prosecute cheating. Okay?
What if we help people with code and whatnot, and it therefore looks similar to ours?
You're encouraged to help each other, but there's ways to help each other in which you're not sharing code. Okay, you can talk to each other. You can share ideas, give explanations, but if you share code, it's going to come back to bite you. If you don't share code and say, okay, I'm so smart, I'll avoid sharing code, but I will just tell my friend X 0, comma, it's going to be obvious. So just don't do it. Because going through the official process of academic honesty infraction is a pain for me, and it's really unpleasant for you. Okay, see here, just you can read up on the penalties.
Can you be prosecuted for sharing it as opposed to the person who actually uses it?
Yep. Both of you go down.
Fun.
What if we get money for it and then split the money with you?
I'll get back to you on that.
All right.
It's still an honesty, though.
Well, we'll take that one on a case-by-case basis. Okay. Good. So, camera's on, all right? The reason why camera's on is, again, if I don't, I can't reach out and touch you. And besides, if I did, it's illegal. But in this format, it's just so isolating and so lonely. And I'm just, think about what I'm doing here is I'm talking to a little black box. If I don't get feedback from you, if you don't participate, it's going to suck for all of us. So you have to talk and you have to interact and you have to let me know there's human beings out there. All right? Okay. Anybody have any questions about the syllabus?
Will you be using Discord at all to communicate?
Our barbecues, which we haven't defined yet, do take place over Discord. I have had the, you know how you never follow through with your New Year's resolutions?
Yeah.
That's Discord for me, right? I always, every semester I say, this is the semester I'm really going to use Discord, and it never happens. I mean, the problem is, in order to be good at Discord, you have to have it running all the time. And then I'm going to hear about, you know, somebody just slayed the boss on level 19 of whatever it is. And while it's true, I'm fascinated by your exploits in video games. I just don't want to have the dinging and the clicking and the all this all the time. So
You can
Discord,
change the notification you can change the notification settings for like each individual channel. So you could like,
Yeah. Or
you could just-
certain channels and like put one to like, if you're in a meeting, you can mute it for an hour. It'll
Yep.
unmute after that
So-
time.
Gabe?
Or you could just mute the tab.
Yeah, guys, don't argue facts when I'm ranting. Okay? It doesn't end well.
You really
Real.
want to use Discord though. I find it much preferred to Zoom.
And not to mention, we can't really send any files for you to look at easily over email now because it's being wonky. Like I had-
What, emails being wonky? What's going on with email?
I had to. My teacher was like, "Okay, can you send me this for previous semester for comp sci?" And I sent them the file 5 times, but they never got it because email is being stupid for Carthage. And occasionally, I'm just not getting or sending anything.
Okay. Well, look, I'll make it's easy to make New Year's resolutions, right? So in this new year, I'm going to use Discord more. Okay?
I mean, you have a thing for Discord, and you can also just like have it on
I
a
will-
tab or something.
Yeah, I will try. Okay, I recognize the value of Discord. I think Discord is an amazing platform. It's just I don't do it very well.
We
So,
can help.
Yeah, that's what I'm afraid of. Okay, so let's hop over to GitHub. Okay, and so follow that link in the syllabus. Let's go back to the syllabus. And the GitHub link is here. Let's see, what, Alt? Click, oh, screw it. Just go here. You know how to,
Schoology is stupid. You can't. Sometimes you just can't click links. It's weird.
yeah, okay. So, all right, so let's go over to screen sharing is stopped because the Window has closed. Okay, so let me share it over again. All right. That will be this page here. Okay, so I have already created a number of basic lessons to help you get over the hump of assembly language. Now, it's my experience. I love assembly language. I could code in assembly language nearly as quickly as I do in other languages, except Python, where it takes only 4 letters to write Minecraft. The assembly language is actually easy, yet most students have a total cow about it. Why? Because, in my view, the difficulty that students have is because they've never seen it before, and it's just a different way of looking at your code. So if you keep an open mind and just allow yourself to let go of braces, assembly language will actually be a lot easier. So what you're looking at I tried to break down some of the syntactical sugar, like a while loop, and express it in assembly language. So if you want, I would encourage you to start with the if statement. And what you'll find is an if in the language that you're familiar with, and you'll also find the equivalent, the equivalent in assembly language, with lots of comments talking about what's happening. So I think, and this is brand new, I haven't done this before, the idea that I have here is I'm going to bridge you from the constructs you're familiar with to assembly language, the same constructs in assembly language. I mean, after all, those constructs in your higher level languages, they're going to get rendered to assembly language anyway. So of course, anything you can do in a higher level language, you can also do in assembly language. So I'm trying to get you establish that bridge for you. So that's what that's what's in this folder. So I would encourage you to start reading this over now. Also, the projects, the first 2 projects are online. You can see them and start on them. You will note that every project this year is different from every project last year. So it won't help much to simply find someone who took the class before. Your projects are here. They're not due until some point in the future. But at least you can start wrapping your head around the projects themselves.
We can write this code in like Visual Studio Code, right? Or just any text editor?
Actually, no. Actually, you have to put it in ones and zeros. That's part of the fun of assembly language.
All right.
All right.
That's not what I see whenever I look at
Yeah.
the other stuff on GitHub.
Yeah.
Isn't that
So,
just machine code?
ones and zeros? Yeah.
Yeah.
That's machine code.
So it's
This
not
isn't
assembly
this
language.
isn't the Adeptus Mechanicus. We don't talk in binary.
We assembly language is the high level language in above machine code. Machine code being ones and zeros. But anyway, to answer your question seriously, you will be able. What's marvelous here? There are 2 ways to go about this. One that I'm going to show you. There's another good way that I believe Cephas investigated, and we added to the documentation here. The way that I'm going to show you how to do it is once you start up your ARM-based Linux machine, you can then edit in your favorite editor, in my case, Visual Studio Code, and in my case, automatically FTP on every single save. It squirts the code over to the Linux machine, and then you can just compile on the Linux machine. Cephas has a different method. In some ways it's superior, some ways it's just different. Some ways you might think it's superior, but I use the method that I use, and that's what I documented. So the idea is you add a plugin to Visual Studio Code that will automatically, every time you save a file, squirt it to a running ARM-based Linux machine. Then you just hop over to the Linux machine, which is just one of your terminal windows, and you can compile and test there. So the editing is done on your local machine. If you want, you can edit on the Linux machine as well, but that you'll probably have to learn VI. Okay?
My method allows you to do both.
Yes. Yes. Cephas's method is in some ways superior.
In most ways, I would argue, but that's just me.
Okay. The reference materials are here. This is the one, that very first one, that's the one to look at. We're going to look at that today, most likely. So let's move back. All right. The next thing on the agenda is the installation. Now, the installation guide is here. And the installation is very, very different on Mac versus Windows. On Mac, you'll need Brew. So Brew is a package manager for the Macintosh. You'll just copy the whole line, paste it into your terminal. Okay? So first you have to install Brew, that's this one, then install QEMU. Right? Then you'll be able to run QEMU directly in your terminal on the Mac. You'll be able to directly use your terminal to SSH log into the emulated machine.
So if we
Okay.
run that bit of code right there, the QEMU system, whatever, what's the expected output for that?
The expected output of this,
Yeah.
it'll tell you that you haven't specified enough options.
Oh, okay.
It'll just give you an error.
Okay.
Okay. So after having installed QEMU, you need to install the distro. Okay, so if you follow this link, it starts downloading. Great. Okay, well, I needed it anyway. So because I deleted everything so that I could reinstall it. What I do is I would, the zip file has a directory named arch64, and I put that in my home directory on the Mac. And then, well, here it is. Okay, so you create the directory, arch64, change directory into it. How many people have experience with the command line? All of you, right? Okay, now I can't see everybody, so
I got
know.
Windows, so no.
Okay, all right. Well, the command line on Windows is a delightful trip back to 1978, so let's ignore it.
Unless you use PowerShell. PowerShell is pretty cool.
Yeah, well, okay.
CMD is kind of garbage.
All right, so what we're going to do on Windows instead, now let me finish up. You're going to need to create this alias because there is a lot of command line options in order to launch QEMU. Okay, so it's unlikely that you'll want to type this stuff in each time. So instead, I give you instructions on how to create an alias so that when you type in ARM, you start up the machine.
Professor,
Yes?
the part where I'm having issues is I make the directory for ARC64, it creates the ARC64 directory, but when I try to unzip the download into the ARC64 directory, it has issues there. So I don't know if you want to wait till after you explain the Windows part, but that's like that chunk of code where you explain how to unzip and create the directory. That's where it's
The Windows, you're on Windows then?
No, I'm on Mac, actually.
You're on Mac. Okay.
Yeah.
Well, I'll probably, I'm pretty sure I actually did delete everything. Did I? Yeah, I deleted everything. So I can demonstrate setting it up on the
Okay.
Mac. All right, let me go back to, what was I presenting? This, okay. Now on Windows, you just don't. Because Windows is primitive. And instead use Whizzle. Now, Whizzle is the Linux subsystem for Windows. So why is it WSL when it's actually spoken as LSW? I don't know, but I didn't create it. And yes, it is GIF, not GIF. Okay, so in order to load Whizzle, you'll have to make some changes to Windows. And the first one is turn Windows features on and off. Let me very quickly show you how to get there from here. Okay, and if you go down here, where did I go? I went to the very bottom where it says type here to search.
Why is
Okay,
your cursor so massive?
because I'm old and blind.
Oh,
Okay.
you should stop.
Stop aging? I should stop aging.
I mean, you're not. What's his name? You're not. No, I was gonna say Deadpool, but person who plays Deadpool.
You should download one of those like cursor skins. I downloaded mine, and my cursor moves by itself.
Oh God. Also,
I'm not
Panzer
sure. I'm not sure I would find that useful. So anyway, go down here and type in Windows features, and the first thing up there is turn Windows features on and off. Click on that, and this is why it's difficult to find. This is the old-fashioned Windows prior to 10 version of settings. And way at the bottom, you'll find Windows. I can't zoom this. All right, next class, I'll make the resolution of this. Actually, I could. This is a virtual machine, so hang on. I'll make this bigger right now just by making it smaller. If I make it smaller for me, it's bigger for you. Go figure. It's all relative. So anyway, Windows subsystem for Linux. Everybody see that? That box has to be checked. Then you hit OK. Windows will do its thing for a little while, and you're done for that.
And then it'll tell you to restart your computer.
Yeah, right. So do it later.
As perhaps a better way next time, you can give them a command to do it from PowerShell.
Yeah, but that means I would have to use PowerShell.
You just look it up and copy paste.
I will never use PowerShell in a class because it's too friggin' dangerous.
Dangerous? How do you mean?
Yes. Well, directly from the command line, you can edit your registry and brick your Windows machine.
You can do that with the Linux command line. You can clear a whole directory. if you wanted to.
Yeah, well, shall we move on? Then go to the, you want to install, so you're not, just, the next step is to go to the Windows App Store and get Linux. I would strongly suggest one of the Ubuntus. The fact 18.04, it could be the 20. They have 20 there now. No point really of going older, right? So install it, launch, wait. Now make a trivial username and password, because, I mean, literally make it like username A, password A. You do not have to protect this machine, because this machine is only accessible to someone who already has access to your machine. Okay, so doing a long password here is pointless. Then you can use the apt, the apt package manager to install QEMU, which in Brew was just say install QEMU. This one is install QEMU-system. Okay, now do it at home, because these things will take a long time. Do it after class, I mean. All right, then the alias is going to be exactly the same as on the Mac. In fact, after this point, everything is the same as on the Mac.
You're still showing the virtual environment you're on the Windows 10, by the way.
Thank you for letting me know. That's a really important contribution to the success of the class, is letting me know that I'm showing the wrong thing. Okay, so all of the steps are laid out here. Now, it is 1:20 and class ends at 2:10. So let me just talk you through this last point. I want to go over don't panic. So I may not actually do the install in live here in class. But let's talk about this. In both platforms, whether you're on WSDL or you're on the Mac terminal, don't use the shell, don't use the terminal window that you launch the virtual machine in. The reason is that terminal acts as the hardware console for the virtual machine. And as such, weird and spurious error messages will pollute the terminal at random times. So instead of using that login directly, you'd open a second WSDL or open a second terminal window on the Mac and SSH into the machine. That one is an ordinary user console, and you won't be despoiled by these spurious hardware messages. Okay? So I talked through that. I will undoubtedly have to demonstrate it. Let's see. I know that
You're still on the.
I know that I'm not showing you what I'm doing right now, so I know that.
He's uploading the quiz answers for everything right now.
Yep, that's exactly what I'm doing. What did I name? Oh yeah, there it is. Okay. So I'm going to switch over to a terminal window. Okay. So I'm in my home directory. How do you get to the terminal? Well, you can, are there any Mac users who don't know how to get into the terminal? Say it by voice. Okay, good. Everybody can get into the terminal. All right, so when you first launch your terminal, you're in your home directory. You see the squiggle there. And in my downloads, I've already downloaded the zip file. So I'm going to make a directory called arch64. I'm going to cd into arch64. Now I'm going to unzip my downloads. What's happening right now is a boot partition. You're actually unzipping hard drives. So VM Linux is the boot partition, and HDA.QCOW2 is the hard drive of the new machine. It's big, so it's going to take a while. Okay, good. So there's my, oh, it actually already contained a, sorry, so I've got a bit of a problem there. So notice I'm in Arch64 and I have a subdirectory called Arch64. So let me fix that. Move Arch64, whatever's in there, into the current directory. And now I can,
Professor,
yeah.
it says that when I go to unzip downloads arc64.zip, it says it cannot find or open arc64.zip in my downloads, even though it's in my downloads. I know for a fact it is, because that's where it downloaded to.
Okay, is it safe to show your screen?
Yeah. I mean, I'm on my iPad, but I can show you what I'm looking at. So yeah, 1 second.
All right, so let me stop sharing, and I have to enable you to share. What's all this stuff in the chat?
I can't really share per se because I'm on 2 separate systems, but that is
Okay.
my window. If it
All right, so let me pin you so I can see it big. All right.
clean this camera. Should focus.
Unzip, can't find.
Did you do the tilde?
The tilde. Yeah, I did. The tilde
It's
is there
there.
for the unzip. Yeah, it's
Okay,
exact.
so here, learn some wisdom here.
Yep.
Use the up arrow.
The up arrow.
Yep. Once.
Yep.
Okay, now hit Control A.
Control A.
And erase unzip and replace it with ls.
LS.
ls and hit return.
Yep. Hit return. It says no such file or directory.
Okay, so it's really not there.
Go to it in Finder.
Go to it and
see.
find. Okay, give me 1
Yeah.
sec. I will.
Okay.
Go to it and find it. Go to my downloads, and then it should be in there. Downloads.
All right. So while that's happening,
Yep.
if you could stop sharing,
Okay.
I will share my terminal again. Okay, so from a previous installation, I have this alias already present. So I don't need to do that step again. Let me look around here, and so I'm going to demonstrate for you what the machine looks like. Okay, so this is another computer, a guest computer starting. It is a Debian stretch. Wait, is this the old? This shouldn't be stretch. It should be, no, yeah, it should, no? I don't know. See, it's supposed to be Buster or stretch. You gotta wait for this to finish. Okay, now you see, you could log in here, but I'm saying don't. Instead, open up and you can do a new tab. Let's see, can you see it? You can't see it. All right, then that means it.
What command did you use to start that up? I missed that.
You're on a Mac, right?
Yeah.
Okay, so here I am. I'm back where you were. I'm going up to the menu bar. The word terminal and then the word shell is next to it. I click on shell and new tab. You could also use new window. So I'm going to use new window instead. Just click on it.
No, I meant
and
what command did you use to start up the Debian thing?
okay, you have to install that alias.
Oh yeah, yeah.
Right. Okay, so let me demonstrate the usage of the machine. So I have to do a new share. I'll just do it this way. Okay, now you can see the whole term, the whole screen. So here is the system console. Don't use it. Instead, in another window, and this is identical on WSL. You'll just open a second WSL. So you'd say SSH user at localhost dash P 2222. Presto changeo. First time you do it, you'll get a request. Do you really want to do it? And you hit yes. So the password is A. Your username is user, and your password is A. Okay, so here's the console. Don't use it. Instead, SSH in.
How would you go about creating a key pair so you don't have to
What?
put in the password? A key, the SSH key, so you don't have to put in the password.
Oh, yeah. I'm sorry, Sivas. It's not that hard, but every time I have to do it, I have to look it up. So you would do an SSH keygen and then an SSH copy. Okay, so
Also, how do you like usually get it to the other machine? You have to
SSH
copy
copy.
from. Okay, I'll look
Okay.
it up.
Yeah. All right. So here it is. I'm on this other machine. Now, if I go, notice there is nothing here. LS, there's nothing there. Now, let me show you how to shut it down. You'd exit this EXIT. Don't just close the window. So I've exited out of my login shell. I can close that. But here, don't just close this because that's like pulling the plug on a real machine. Instead, log in as root. Password is A. And you know that you're root because instead of a $, you have a pound sign. And then say shut down now. And it'll undo the process that it went through. This is the only safe way of powering down the machine. And now I'm back on my Mac. All right. Let's go over this document. Now, the steps that you see here is largely project one. Okay? Now, does anybody have any difficulty understanding this code? Oh, you know what? That's unfair. Some of you may have never seen argc and argv before. Is that true?
That's true for me.
Oh, okay. Okay.
Same here.
Yep. Okay.
Same here.
Very good. Very good. Right. Okay. That's because other professors in the CS department don't cover the command line. When I do 1810, I cover the command line, but other professors don't. So let me, let's see, code, Visual Studio Code. All right, I'm going to switch to the share. I'm going to do a real quick lesson on argc and argv. Oh, I'm already showing. No, I'm not. Where is it? There it is. Okay, so you can see my Visual Studio Code. Let me start a program. No, so let's see, open and go to /temp and then open, okay. New file. Now this you will have, just follow along. So that's usual, using namespace std, that's usual. Now on the Macintosh, every time you start a program, it begins with this. On Windows, every time you start a program, on Visual Studio, for example, it starts with this. So that's why many of you will have never seen argc and argv before. Both of these are valid. This is the version that is most technically correct.
Why is that the case?
Because command line arguments are fundamental to the operation of the computer. The version that Visual Studio gives you doesn't let you have access to them. The version that Xcode gives you is the one that is more general, more technically correct. So I'm going to eliminate this one, and let's talk here. The arguments are an integer, which is a count of command line arguments, and then you can write the second one, which is the command line arguments themselves. I've got a video on this, so I'll get the video out to you. You can write it two ways. Both ways are, they're syntactically they look a little different, but they mean exactly the same thing. So char star argv array is identical to char star star argv. Okay, so that means that argv is a pointer to an array of char pointers. So let's make use of it. First of all, let's find out what argc does for us. So argc, and that's all we'll do. And okay, so now I have a C++ file. Let me open up a console. And what did I call it again? Args? Yeah. And I just did GCC, didn't I? Okay, let's instead use G++. Okay, thank you. So I'm running it now on the command line, and this is the command line. So I wonder what the value of argc is. And the value of argc is 1. Let me try giving it some actual command line arguments. 1, 2, 9, 10. Now it's 5. Let's count. Remember, we're starting at 0, so 0, 1, 2, 3, 4. How many altogether? 5. That's why the number is 5. So the first thing that you'll observe is that argc is never less than 1. It is always at least 1. Now let's find out what's in it. Okay, so how about we'll do it as a for loop for int I equals 0, I less than argc, I plus plus, and
Just make an infinite loop.
no, not today. Don't
Okay.
have time. That would be fun some other time. All right, and one more brace. Let me give you a moment to get that down. So this loop, lines 7 through 9, is going to enumerate the array of pointers to C strings. So I'm going to repeat the very first invocation, which has seemingly no command line arguments, but we discovered that argc is always at least 1. So what is it? I should probably build the program again. There. Okay, so argv sub 0 is always present, and it's always the name of the program that you just ran. Okay, now how about running with all of these? Okay. Now, what would you use this for? Well, this is how I could say ls, or I could say ls minus l. Okay, that was a command line argument. So I can customize or specialize the invocation of programs from the command line by varying and manipulating the command line arguments. Now, where I use this for in like in 1810 is, remember when you were learning how to use files and you would open a file, you need a file name. So the way I teach it is you would, instead of hard coding the file name, you could put the file name right here. All right, so that's why I do it that way. But suffice to say, is everybody on board now with what the command line arguments are?
Mostly.
Okay.
To a degree, but I use Windows, so I don't know if I'm going to be utilizing it as much as I should be.
You will be using this, certainly at least to do this class and also to do operating systems next fall. But you know, hopefully you'll get to a place in your career. It's almost certain that as you go out into the workplace, you'll be in places where they use the command line, not the frou-frou GUI interfaces. This is where the real work happens.
Depends upon the programming gig, but yeah.
Okay. So I have a video explaining argc and argv. So this was just a quick introduction. Let's go back to the document here. Now this is a different way of writing the exact same code that I just wrote. Instead of using a for loop with a counter based on argc, I'm using the array itself with the foreknowledge that the last member of the array has a value of 0. So remember, C objects, C doesn't have any soul. C++ has a soul. Like you can ask a vector, how big are you, vector? And it'll tell you. But C doesn't have that capability. So when you have something like an array, how big is the array? Well, there's no way of knowing unless you put some type of flag or sentinel is the correct word, some type of sentinel at the end of the array. Typically, that's a null, a 0, a null pointer, right? So you did cover C strings, right? That's a null terminated string. So an array, a string is an array, a C string is an array, and it's null terminated. When you hit the 0, that's how you know you got to the end of the string. In the case of argv, there's argv sub 0, which is the name of the program, and then argv sub 1, 2, 3, however many command line arguments you gave, and then a 0. So a 0 is always the last thing. And that's what this while loop is leveraging. So this code is exactly the same as the one with the for loop without the for loop and without the extra temporary variable I. Okay, now watch what I do here. To go from version 1 to version 2, what I'm going to do is deconstruct this code. First, I'm going to shift from C++ to C. Nope, I haven't done that yet. Instead, I'm getting rid of the while loop. Now take a look. This is a label. It's valid in C++. And also the word goto is a keyword that I doubt any of your instructors have ever shown you. So what you're looking at is exactly the same as the while loop. That's what a while loop is. So here's the decision box, while star argv, do some code, go back to the top, right? So you see how this set of, I eliminated this set of braces. That braces, not the ones that are necessary to have a function, but all of the other braces that you might use, which define scopes, are actually labels and gotos. Okay, so that was step number 1. So far the code is the same, it's still C++. Let's go to version 3. And now I've turned it into C instead of C++. No, specifically, I don't have IOStream anymore. Instead of IOStream, I'm using a function called puts. So puts takes a pointer to a C string and prints it followed by a new line, which is identical to all of this. Okay? But we still have braces inside the function. These I can't do anything about. Okay, remember, the ones that are part of the start and the end of a function, can't do anything about. But I'm going to eliminate all the braces inside. Look at that. The only braces that are left are the ones that are necessary to enclose a function.
With
So how does, yeah?
with puts, is there a separate way to do it if you don't want an end line?
Yes, you'd use printf.
Oh, okay.
But we don't need to explain printf today, although we'll have to explain printf real soon. So take a look at this dance here. You got a label, and then an if statement, and then go to bottom, and another label, bottom. Go to bottom. Where is that in the previous version?
Is that the closed brackets of the if statement?
Exactly. And it's a brace. So you got three kinds of punctuation: braces, brackets, and parentheses. These are braces. Okay, so you see what you got here in this C language? That is assembly language. C is a high-level assembly language. Because now let's take a look at it in ARM 64-bit code. And I draw your
I have no idea
attention.
what the heck that means.
Watch. I draw your attention to only the code here. You got the same labels, top and bottom. So this says, well, this previous statement says here x1 is where argv comes in the assembly language. By the way, that's something to learn right now. You see your two parameters here? They'll come in at register 0, register 1. And in our case, this is an X register. You don't need to know why it's an X register. That's explained in the next class. So X1 is argv. That's all you need to know. So I'm going to save X1. The way that you read this is move X1 into X21. The reason the move is necessary is function calls. There's a function call right there. Function calls will destroy the contents of some registers, but not of others. 21, register 21 is not destroyed by function calls. So I'm going to save it. So that's argv. Argv is right there. X21 is argv. And look at this instruction here. It is the same thing. What this means is putting the value of what's pointed to right there. What's pointed to, that's what the brackets are doing. what's pointed to by x21, put it in x0, and then increment by 8. Why is it by 8?
I have no idea.
Is that referencing like the bits or the bytes in memory?
So we're working on a 64-bit machine, and we're using addresses, right? Because what is argv itself? It's a pointer. What is a pointer? It's an address. So how many bytes are in 64 bits?
8.
8. And that's why that's 8. So that is argv++. The brackets are the dereferencing. So that star is here, and the plus plus is that. Here's an if statement. Compare x0, look at x0, and if it is 0, go to bottom. Let's look at this upper level. Look at what is essentially, what is x0, what's in x0, and if it's 0, go to bottom. If it's not 0, we do a puts and a go to top. So if it's not 0, we make the function call to puts and we go to top. So it's 1 for 1.
So
C, yep.
So the CBZ, the compare, that, how does it know to compare x0 to null? Is that just default? But if, where would I specify if I wanted to check if it's something else?
So this is compare and branch, that's the B, if 0, that's the Z.
That makes sense.
I have a question.
Yeah, go ahead.
So why does LDR have the option to increment by 8 bits?
8 by decimal 8.
By
Here.
what? Decimal 8?
Yes. So you keep talking, and I'll hear your question, but I'm going to shift over to the iPad so I can start writing a picture. Go ahead, Cephas. Go ahead, talk.
I don't have anything to say. I just don't quite
Okay.
understand that.
You ready? So here's what it really looks like. So argc is an int. Argc, let's say that's 3. If argc is 3, that means argv is now I told you before, argv is a pointer to a pointer, to a pointer to an array of pointers. Well, here's a pointer to an array of pointers. So the command line was ./a.out 1, 2. So here's a pointer to a pointer to an array of characters. And that's at 0. Look, there's argv sub 0. Here's argv sub 1, and that is a pointer to the characters O, N, E, and by the way, null, null, there's a 0 at the end. Here's argv sub 2, and that is a pointer to TWO, null, and then null. Now, your question was, why 8? The reason it's 8 is this is a 64-bit machine, which means addresses are 64 bits or 8 bytes. So argv plus plus means go from this address. Let me get another color here. Go from this address, go forward 8 bytes, and then you get to this address. That's argv plus plus.
Okay, so my main confusion was on the syntax of the LDR command.
Okay.
So it gets an address and you can possibly, I guess I'm not quite certain.
Okay,
maybe.
so well, it's quite excusable that you have a problem with the syntax because I haven't explained any of the syntax yet. So in general, ARM instructions have a mnemonic or opcode like MOV, LDR, add, subs for subtract, mul for multiply, and then, whoops, go away. In general, they are 3 operands. So let me demonstrate a typical 3 operand instruction, which would be add x0, x0, 1. This is the same as a equals a plus 1. So it says add 1 to x0 and put the results in x0.
So what does the LDR command do specifically?
Okay, the LDR command, now this is skipping forward a lot, but on the ARM processor, in fact, on all modern processors, you can't do anything to memory except to read from it and write to it. So you can't, when you have a variable, the way that you've always thought about this is you have a variable, let's say, int a, and then you said a equals a plus 1. Well, the way you always thought about this is a is in memory, right? So you added 1 to a location in memory. But that's not how it actually works. So here is where the scales begin to drop from your eyes. Instead, it is A has a location in memory. It has an address. So in order to do A equals A plus 1, there would be an LDR. Well, let me do it correctly, technically correctly. ADR into x0 of A. And A is an actual label. So that's the address. What is that? That's the address of A. So now the address of A is in x0, not the value of A. Now we need LDR This says the address of A is in x0. Dereference the pointer and put the value of A in x0. which actually is a bad idea. So let me rewrite that. The reason why it's a bad idea is in order to put the value back, I need the address of A again. So let me do it differently. ADR X0 of A. Son of a bitch. Can you still see me? I'm still
Yeah,
on,
we can
right?
still see. Yeah,
Yeah,
you're
you're
still
good.
on the notebook. We can see what you're writing.
Okay, because I'm getting a phone call. Must be somebody died. It's a cousin I haven't spoke to in 20 years. I'm getting a phone call, and the other Mac responded to the phone call, and it bumped me out of Zoom.
Hmm.
Okay. All right. So, like I said, it's a cousin I haven't spoke to in 20 years. So somebody died. All right. So LDR into X1 of what's at X0. Okay. So go back. This is the address of the variable A. I'm going to put the address of A into X0. Then that's a pointer. Address, pointer, pointer, address, address, pointer, pointer, address. Synonyms. This dereferences the pointer and puts the value, whoops, that was the wrong tool. What I wanted to do was change color. This is the value of A is now in X1. Here we do the add 1 to the value of X1, putting the results in X1. And guess what? There's a reciprocal instruction for LDR, str, store. Take the value that's in X1 and put it back in, dereference the pointer.
So just to confirm, LDR is basically saying take whatever's in register 0 and put it in register 1, or copy it over to register 1.
No, that would be move, MOV. Transferring between registers is MOV, but transferring between a register and memory is ADR, LDR, and STR.
Okay.
And you got to use all of those in order to do this.
In general, yes.
Oh, jeez. What?
It's fun.
If you smell
Trust me.
something burning, it's me thinking.
Yeah, more or less.
Okay, everybody. Okay, everybody.
Don't panic.
Don't
We're
panic.
not knocking you, we're knocking the concept.
Okay, but here's the point. You actually know all of this, so allow yourself to let go of the trappings of C++, because this is how C++ is built. This is what it is doing. Okay? So if you cling really tightly to, no, it has to be with braces and it has to be with this, you'll never get assembly language. Just take a deep breath, let it go. Okay?
My head's already pretty empty, so it's not that surprising.
Yeah. All right. So coming back, we only have 0 minutes left. Coming back to here, please go over this again and again, and also start with language concepts, do the if statement. So here is a version of maximum written in C. By the way, here's your first instance of C of printf, but don't worry about it. So here it is in C, but then take a look at it in assembly language. It's the same code. Now, your first thing that you may ask is, you can see the screen, right? First thing you may ask
I
is
am able to.
why is it a W and not an X? Well, X is 64-bit integers, W is 32-bit integers. And I'll explain that again in the next class. All right, so let me recap. How are you? Let me tell you how you're doing. You're doing great, right? The most important thing to me is to deliver a quality product, and I can't do that if you're silent. So keep on doing what you're doing, okay? Keep on talking to me. Give me your. I'm feeding off of your energy. If you're a bunch of black boxes, then I'm miserable. And if I'm miserable, sooner or later, you're going to be miserable too. Okay?
What type of black box? The black box where you don't the only info you have is what goes in, what goes out, and
No,
you have to make everything else, or a blank
like
box.
Is somebody with their camera off, right? So I need to be able to interact with you folks. So you're doing great. So thank you, and I'll see you on Thursday. I'll get some of those videos uploaded for you.
Thank you. I'll try to wrap my head around this while
Yeah,
also trying to learn German.
We could do assembly language in German.
God, no.
Can we do that? Can we do that, please? Can we do that?
God, no.
The 4 years of German I spent in high school is now not going to be useless.
Well, I'm also taking stats.
Okay. We'll see you on Thursday, and I'll try to get uploaded. This will be uploaded, and I'll try to get some more videos uploaded for you. Okay?
Thank you.
Thank you for
Yeah, thank you.
uploading the video. That's going to help me a lot.
Oh, by the way, the recordings of class will have subtitles. And
What
if you
poor
go,
man has to? What poor man has to write out those subtitles?
somebody in Pakistan.
Dibs. Oh,
AI.
can we get director's commentary?
No, I gotta go. Gotta teach another class.
Good luck.
Bye-bye.
Yeah.
You wanted to see a little black box.